When we're talking about this particular topic, the first thing that comes into our minds is what is atmospheric pressure? High pressure does not mean it has to be high. It is a relative term in comparison to the other pressure to which you are comparing. You very well know in case of the Himalayas also. If the winds are coming, if the moment a barrier, supposing any mountain barrier also comes, it is going to get deflected to the either directions. So this moving down is known as the mountain breeze during the night time. Coriolis force basically helps to form the cyclones, right? Because of the because of deflection that is caused. Hello aspirants, welcome to PW OnlyIAS. I'm here preaching with another very important chapter from the physical geography series. This chapter is atmospheric circulations and weather system, lecture number 9. Please remember, this topic is important not only for your preliminary examination, but also the mains examination. Particularly topics like what is air mass, what is tropical cyclone, what is temperate cyclone. So these concepts have been explained very well in this particular lecture. So while listening to this lecture, make sure that you can pause the video, note down whatever diagrams that I have drawn, re-see the video again if you want. Please make sure that you understand the concepts. If you have any query, the comment section is always welcome. You can definitely ask your queries. I'll be very happy to respond to them. So let's begin with today's session, a very important session for the civil services examination. This is a QR code for the Telegram account. This is my Telegram account, which you can subscribe to. You can very easily get access to these PDFs, along with anthropology optional, along with society, social justice, and general guidance for the civil services examination. So let's begin. When we're talking about this particular topic, the first thing that comes into our minds is what is atmospheric pressure? When we study these atmospheric pressure definitions, this you would have already studied in your geography sessions while you would have been studying in your school, or even in the physics chapter, or when if you would have studied physics in your school days. This is something very common, but let us understand this also. See, what is atmospheric pressure? It is defined as a total weight of a mass of a column of air per unit area at a sea level. Now let us assume this is a sea level. Now, if you are standing here, this, let us say, a column of air, that means some form of weight is being exerted by the air also. So what does it mean? The total weight of a mass of column of air per unit area at the sea level. So what is the weight being exerted? This is referred to as the atmospheric pressure. That is why you realize that your atmospheric pressure needs to balance the blood pressure also. So the balancing stuff is there, then only you can basically survive. Otherwise, what happens? When you go to higher altitudes, over there the atmospheric pressure decreases, but your blood pressure is relatively what it used to be. That is why you have nose bleeding and all. Clear? So that is why this is the definition of atmospheric pressure. Now what it is? It is 1034 grams per centimeter cube or 1013.25 millibar of mercury. Now these are both things which are again standard, which you need to know. Now please understand, this is something very, very important. Vertically, 10 MB decrease per 10 meter of height is generally seen in the lower atmosphere. Now, this is a fact that is written in the NCERT, and you won't believe that this particular question has been asked in the PCS examinations repeatedly in the Uttar Pradesh PCS as well as Uttarakhand PCS. And this has been asked in your UPSC Prelims also long time ago. So with every 10 meter height, there is a decrease of 10 millibar, right? Now, this is something that you should be aware of as a fact. Now, this is applicable in the lower atmosphere, obviously. So, this is again, you should remember. Clear? This is what is atmospheric pressure. Having now understood this, let us come to the topic that we are studying here. Very often you hear low pressure, high pressure, low pressure, high pressure. Now, have you ever deciphered what these sentences or statements basically mean? Now, let us today decipher it and understand it in a very proper manner. Let us see a very simple example. Let us assume, students, supposingly this is a chair, right? Right? This is a chair. Now imagine yourself that this chair is made up of iron. What? Made up of, this chair is made up of iron. Clear? Done? If you remember this example, you will never be confused with the concepts of particularly this low pressure and high pressure, right? Get your logics clear, get your concepts clear. That is more important. Now let us assume you as a person sit on this. Supposingly you sit on this, right? Now what I do is, please understand, when you are sitting on this, when sitting, that means you basically sat on this chair. When sitting, you are exerting pressure. Pressure on the chair. Obviously you are, because you have weight. Now let us take a very simple understanding. What I do is, I light fire over here. What I do, you're sitting on that iron chair and I have put certain woods and I've lightened that. Now slowly, what will happen? The temperature of the chair will increase. What will happen? What will happen? Temperature will increase. Yes. Now just tell me one thing. Till the time the temperature was fine, you were sitting, you were enjoying yourself sitting on the chair. Now I have increased the temperature. This will heat in the chair, iron chair. Yes. Now do you realize after some time you will start feeling hot? What you will do, you will jump from that chair. What you will do? Because of the temperature increase, you will jump Can I say when you will jump, there will be decrease in pressure on that particular chair, or there will be lower pressure what it used to be? Can I say when you jump, because of the temperature that have increased, now the pressure being exerted on the chair is much less, that means it's low. So can I say now lower pressure is existing? You will say yes, sir, because the temperature became high, and because of that it was unbearable for me or for you for that matter, and you jumped from the chair. What did you observe here? See, when the temperature increased, you, what did you do? You jumped. You jumped and went somewhere else. Yes? So what do you understand by this? In geography, what happens is, now this was a basic understanding which I wanted to tell you so that you understand from this analogy. What can we basically understand? I will go to the geography part, don't we need to worry about that. But what do you understand from this? You understand that when the temperature is increasing, something is rising and the pressure that was there is decreasing. That means low pressure is being created. Low pressure and high pressure are relative terms. Supposingly, if there is pressure of 1 millibar somewhere, another place it is 2 millibar. Again, this is low pressure, this is high pressure. Even if it is, let us say, 1000 millibar and it is 2000 millibar, then also this is what? Low pressure, high pressure. It is relative, right? It is relative. Now, what we are trying to say is you will jump. So that means decrease in pressure. Now, similarly, can I say something? Supposingly, this is some region. In this particular region, let us say this is some island or something, some place. If the temperature increases here, what will happen here? What will happen? The air present over here will get heated. The air present over here will get heated and it will rise. When the air will rise, it will rise over here. So it will create what? Low pressure over here because it has risen. So what will happen? A low pressure will be created here. Now you know something very well. Anything that has risen will go upwards. It might move here or there, whatever. But somewhere when it cools down, it will sink. When it sinks, it will create high pressure. Somewhat very similar to this. Supposing you have heated the chair, you have jumped. Afterward, it cools, you again sit. When you sit, you exert pressure. So what is here? Whenever there is sinking of air, that means it will lead to what? High pressure situations. Clear? Whenever there is temperature relatively increase and the air is rising, what does it do? It will lead to low pressure. Now, high pressure and low pressure both are relative. High pressure does not mean, supposingly, please understand this. If I say 10 millibar pressure and I say 900 millibar, obviously this is low pressure, this is high pressure, no problem. Clear? No problem. Second thing is, if I say 10 millibar and 11 millibar, then also this is low pressure and high pressure. High pressure does not mean it has to be high. It is a relative term in comparison to the other pressure to which you are comparing. So it is relative. One more thing you need to understand. Now, just see here, when the air has risen upward, this region has become vacant, so the air that had fallen down here will move here. This is at the ground. Please understand. This thing is taking place at the ground level. This thing is taking place in the upper troposphere. Let us say to a certain height, you can say, the upper in the atmosphere, let us say at some height, So this is what surface level, this is up in the higher in the atmosphere, let us say 5 kilometers, 10 kilometers up, right? Can I say something? Air moves from a region of high pressure to a region of low pressure. What I'm saying, air moves, what is, see, simple word, air is stagnant, or moving air, let us say wind, or that means simple words, air only. It moves from a region of high pressure to a region of low pressure. Now you will say one thing, sir, how is it that over here upward, so it is moving from low to high? It is not low to high. Please remember, if you ever study in advanced geographical concepts, whenever there is low pressure here, there is a high pressure induced over here. When there is high pressure here, there is a low pressure induced over here. Here also from high pressure to low pressure. This is in the upper atmosphere, right? And over here also high pressure to low pressure. At the lower ground level, you see high pressure to low pressure. So there is a movement that is taking place. Movement of the air takes place from a region of a high pressure to a region of low pressure. So the movement from a region of high pressure to a region of low pressure. Why again understand? Because the region where temperature is high, relatively high, the air rises up. It creates a vacant space here. So some other air or wind will come here and takes its place. So that is why what happens, the regions which are for high pressure regions, because there is sinking of air, they will move to other regions. So they will move to the regions of low pressure. So in order to occupy that place which had become vacant. So that is why this thing happens. So what do you understand by low pressure and high pressure? Relatively, it is again relative concepts. Both are relative concepts. So this is basic understanding of high pressure and low pressure that you should be knowing. Clear? As I've explained you here also. Now, something again very important, isobars. You've already studied isotherms in the previous chapters. What do you mean isotherms were, what were isotherms? Isotherms were regions, these are lines basically joining regions having equal temperature. That was isotherms. When I talk about isobars, it basically refers to the regions having equal pressure, right? See here. These are referred to as lines joining places having equal pressure. Equal pressure. Atmospheric pressure. Now the important clause over here is that everything while we are dealing with isobars are reduced to the sea level. Bracket, reduced to the sea level. I'll tell you what it means. Reduced to the sea level. This is something that most books do not write, but you should know. Now please understand something. You said, what does this word mean? Isobar, we understand that regions having equal pressure or demarcation, it's fine. But what do you mean by at the sea level? Now let's see one thing here. Let's see this horizontal distribution of pressure in January. Now you know that very well. Let us assume this is an isobar. These are isobars. All of these are isobars. Now you know that over here, a lot of mountains might be present. There might be plains. There might be so many landforms and topographic features are present. Now, if we start calculating that fact with every atmospheric, with every landscape that is present, it becomes very difficult to compute it. So this map that is present in front of you assumes that all the regions are at the sea level. They are not taking into consideration the landforms that are present here. Landforms, that means mountains or plateaus that are present here, they are not taken into consideration. They are considered as almost equivalent to the sea level. This is a very, very important critical point that everybody should be aware of. UPSC long time ago had asked this question, as one statement was isobar and second was it is reduced to the sea level. So that means let us say mountain is present. We assume that mountain is not present at a sea level. So what will be the isobar? It is assumed that, so that it is easier to calculate also. Clear? Now, just a brief representation of these, because when we'll study the further concept of the pressure belts, then it will become easier. But let's see. Horizontal distribution of pressure in January. You will see during the month of January, you realize that the direct sun is directly over the Tropic of Capricorn, right? So what happens is it has shifted towards the south. So this region over here has a relatively higher pressure. Higher pressure. Now these regions are high pressure. So this is just a representation. Obviously this is referred to as ITCZ. We'll understand the concept of ITCZ also. So this is basic representation. And similarly, if you realize in the month of July also, the sun basically is directly over the Tropic of Capricorn. So this is a region where a lot of heat is being thrown. So that is why low pressure regions are being exerted over the land surfaces also. So this is a basic representation. We will be going into the detail, only then you can understand. Now, when you see these diagrams, or let us say these maps, it becomes relatively difficult to why these things are there, right? For this, you need to understand the concept of pressure belts also, how the pressure belts shift. Once you understand that, then this diagram, these isobars and maps become very easy to understand. Let's see them first and then we'll return to this point. Okay, first of all, when I'm talking about air and wind, you should understand what is air and wind. Air simply means stagnant. Wind means air in motion, right? When the air is where air is moving, that is wind. So sometimes people say air moving, it is not incorrect, but the more precise word is when moving air is called wind. Clear? Now the question arises is when we are talking about so much about pressure system and all, pressure belts and all, which we're going to study now, we should understand what are the factors that are impacting the winds also. Only then we can understand the concept of pressure belts, which we'll be studying. Now please understand, what are the factors impacting the wind motion? First topic is pressure gradient. What do you understand by the concept of pressure gradient? A very, very important concept. Now see, what does it mean? It refers to the rate of change in pressure per unit horizontal distance. See, let us understand this. What are these yellow lines? What are these yellow lines? These yellow lines are isobars. Yes? Isobars are representing regions having equal pressure. So let us assume this region, this yellow line is 1020 millibar, right? 1020 millibar. This is 1016 millibar. This is 1012 millibar. 1008 millibar. 1004 millibar. First thing, tell me, which region has high pressure? 1020. This has low pressure. So by default, you know that wind will be flowing in this direction. Do you realize these isobars are very close to each other in this region, but over here they're far off? Yes, these lines, yellow lines, are very close to each other over here, but they're very far off from here. The motion of the wind is from which direction? From a region having high pressure to a region having low pressure. So by default, this is high pressure, this is low pressure. The wind will be moving in this direction as shown here. Agreed, no problem. But what I am referring to over here is a pressure gradient. Pressure gradient means the rate of change of pressure. Now, when the pressure gradient is high and whether the pressure gradient is low will be influenced how close the isobars are. Over here, do you realize that within this small distance, the pressure, these isobars are very close and it is changing from within a very small span of distance, the pressure is changing very rapidly. So that means the rate of change of pressure when this horizontal distance is very fast. So it means that the pressure gradient is very high, the speed, the wind speed is also going to be very fast. Right? So see here, over here what is going on? In this huge distance, the pressure is again changing, but the distance is very huge. So the rate of change of pressure is less in per unit distance, right? So what will happen? The speed of the wind will be relatively low here. Again, understand this. When I talk about pressure gradient means the rate of change of pressure. So over here, this is also 1020. This is also 1016 as I have mentioned here. 1012, 1008, 1008. This is 1004. Same isobars, right? Same isobars. But what do you see here? Here within this small distance, the change has taken place. Over here, such a long distance. So the pressure gradient is high over here. It is low over here. So the wind speed is going to be very high here. Wind speed is going to be very low here. So pressure gradient refers to the rate of change in pressure per unit horizontal distance. Now what happens? Higher the temperature difference, steeper the pressure gradient, and faster the speed of the wind. Clear? This is pressure gradient. Now let us move ahead. Coriolis force and Ferrell's law. Now these two concepts are very, very important. 99.9% students confuse this when they write the statement. What I have written on the board, please make sure that you understand it well. Firstly, many people when they're writing their answers about Coriolis force, they tend to mix with Ferrell's law. And that is where the problem starts. In the civil services preliminary examination also, they can ask you, which among the following is basically solely dedicated to Coriolis force or Coriolis effect? See, why sometimes people say force, it is basically an effect and outcome of the rotation that is taking place, right? So it is sometimes not even called as a law also. So please understand, it only says certain statements, the other statements are added by Ferrell's law. See what is the difference here. Coriolis force or Coriolis effect is basically an outcome of the rotation of the earth. First of all, it is an outcome or effect of the rotation. What it says is, it simply says that the force of deflection due to rotation of the earth. That means it says simply, because of the rotation of the earth, when the wind is moving, there is deflection. It does not say anything right, left, this and that. No. Please understand this very well. There are certain books who have written it completely wrong. The actual description is that it basically says that there is, due to this effect, because what is this effect? Rotation of the earth. There is deflection in the direction. That means the direction which is moving, it is deflected. It does not say anything else. Further, it affects the wind direction, not the wind speed. It is maximum at the poles. This is the only thing that is mentioned by Coriolis force or Coriolis effect. Now the concept whether it is deflecting towards the right or whether it is deflecting towards the left is mentioned by Ferrell's law. Clear? So what is basically Coriolis force? Coriolis force is basically an outcome of the rotation of the earth. That means it says when the wind is moving due to the rotation of the earth, it will be deflected. What is the deflection not being mentioned? Now see, understand Ferrell's law. Now Ferrell's law is basically explaining you this particular diagram which you need to understand. What it says, see, I'm mentioning the exact statement, what Ferrell basically stated. If one stands with his back towards the wind direction, let us see this. Supposingly, this is a man, right? And this is his back, right? This is his back. He's looking this way, looking forward, right? Looking this way. Right? So this is his back. Now what is it saying is, if one stand with his back towards the wind direction, that means the wind is blowing from this side. That means if I'm standing here, the wind is coming in this direction. It's coming from my backside, right? Coming from my backside. So that means on this backside, it is moving, right? So from my back, the wind is coming. The wind is deflected to the right in the northern hemisphere and to the left in the southern hemisphere. Now, supposingly, if this man is standing in the northern hemisphere, the wind which is coming will be slowly deflected towards the right. In where? In northern hemisphere. And it, or if he is standing in the southern hemisphere, it will be deflected towards the left. In the northern hemisphere, left in the southern hemisphere. In the southern hemisphere, right? Now you need to understand something in simple words. What does it say? Supposingly, in whichever direction you are moving, you have to deflect towards the right, if you are in the northern hemisphere, towards the left in the southern hemisphere. Let's see here. Can I see that supposingly this is the direction in which the wind is moving. But this is what? This is the northern hemisphere. This is what? The southern hemisphere. What does Ferrell law say? That it is, if the wind is moving, right, it is deflected towards the right. So what happens? It is deflected towards this right. Now, supposingly, the wind is moving in this direction. It is deflected towards its right. You forget, just when you are in the northern hemisphere, you just remember this, that whichever direction you are flowing, you will turn towards the right. Similarly, supposingly, the wind is moving in this direction. See here. The wind is moving in this direction. It will be deflected towards its right. Now the wind is moving in this direction. It is deflected towards its right. So do you realize, in the northern hemisphere, it is deflecting towards the right. In the southern hemisphere, deflecting towards its left. Now see here, if the wind is moving in this direction, it is deflected towards its left. If it is moving in this direction, towards its left. This is what is Ferrell's law. What happens is, many people tend to write all this statement for Coriolis only. But see, people generally tend to, if you're writing also, you need to mention very categorically, this is Coriolis effect and this is Ferrell's law. I hope it is clear to everybody. This is a very basic concept and this is why you should be understanding. This is something that will be repeatedly asked in your examinations. Let's move ahead. Frictional force. Now you know that very well. You know what is friction. Friction is basically resistance to the path of the motion that is taking place. Every single body that is present, if I'm walking over here also, there is friction between the shoes that I'm wearing and the surface. That is why I'm able to stand, otherwise I would slip. Similarly, when the wind is moving, you know that very well there is going to be friction, particularly which are in the lower altitude, because there are going to be trees, there are going to be buildings, there are going to be a lot of stuff which is going to basically impact or resist the movement also. So see here, the force exerted by the Earth's surface which slows down and modifies the wind direction. Obviously, supposing there's a building here, or the wind is coming, it's going to hit, it's going to deflect. If there is, you very well know in case of the Himalayas also, if the winds are coming, if the moment the barrier, supposing any mountain barrier also comes, it is going to get deflected to the either directions. It works opposite to the direction of the wind motion, obviously, because why it works opposite? Because it is a resistance force. Strongest near the surface, decreases rapidly with height. How does it decrease rapidly with height? Because you know that very well, the trees, the buildings, and all those landforms are not present after a certain height. So let us assume here, let us assume that this is the movement of wind that is taking place at certain height from ground base till some kilometers high. Okay. Now what happens? Supposingly at the base level, you have what? Certain buildings here. You have certain trees here. So what is going to happen? This will again be deflected some direction. It is going to be deflected certain direction. But over here, as you move beyond certain height, the resistance forces will obviously decrease. So this is again what is friction happening. Obviously, when there are so many landforms also, they're also impacting it in various ways. Okay. Last comes centrifugal force. Now, centrifugal force is an outward force. Centrifugal force is an outward force that appears due to the air moving along a curved path. It tries to push air away from the center of curve. Now, supposingly, some wind is moving in circular path. You know that whenever you are moving in a circular path, there is an outward force that is exerted at every point. This is known as centrifugal force. Centrifugal force, right? Okay. Now comes the next very, very important integral part. This is again the latitudinal distribution or the pressure belt systems. Now I'll just explain you one thing very clearly. This is the diagram which you generally see in most of the books when you are reading also, and most of the books when you have been studying since I think class 6 also, and even before. These pressure belts that you see are not as they are represented here. Actually, when you see, these are like these broken patches or in a certain groups, not in continuous blocks. These are not continuous lines pressure belts. These are like these, right? Broken patches, broken areas, because to simplify it, we have drawn it in this manner. And we're continuing with this manner only just to understand it. Now, please understand these things. Every single pressure belt that is drawn here, I'm going to explain it also, don't need to worry. Just quickly, when you are understanding, note these down. Again, these are again, please understand, when we are mentioning these latitudes, they are not exactly mentioned here, present here, because you know these are not simple zones. They might be broken, they might be twisted, they might be shifting up and down. And please understand, because you know the tilted axis of the earth, and along with it, you know that during the summer times or during the winter time, we see that the sun rays are horizontally over, let us say, over Tropic of Cancer or Tropic of Capricorn, or for that matter, over equator. There is shifting of pressure belts also. So we will be seeing that also. The shifting also happens. It is not fixed. It is just a simple representation that we are seeing here. So what happens generally, between 5 degree north and 5 degrees south, there is equatorial low pressure. Between 25 to 30 degree, there is subtropical high pressure. I'll be explaining you the reasons. Between 60 to 65 degrees Celsius, there is subpolar low pressure. And on the top, there is polar high pressure. Polar high pressure. Similarly, it exists in the southern hemisphere also. Now, please understand this thing. If you know that very well, I had told you, winds blow from a region of high pressure to a region of low pressure, right? And the winds which we talk about, some of them are the surface level winds, some are higher, upper atmospheric winds. You remember that? Why do these upper atmospheric winds flow? See here. These are surface level winds, and there are upper winds also, upper atmosphere winds, because you have to balance this. If these winds, let us say the wind is blowing from here to here, because let us start here. If there is low pressure, it will rise. This is vacant space. So some other region, from some other region, the wind will come here from a higher pressure region. Similarly, this region has become empty, so it is moving and it will sink because it has cooled. So this is the two systems work together. One, the surface level winds, and there are upper winds, which surface level winds you can perceive also. Like you can generally aware, we are generally aware also, we read of this. The higher atmospheric winds are something geographically you study, because these are not visible also. Now what we see is, Not visible is not a correct word, not perceptible, you can say, because we cannot see air also as such. It is perception that we talk about. So see here, let's see. When I am talking about these winds, trade winds, westerlies, easterlies, these are surface level winds. What? Surface level. Now see it from the side. Firstly, I will tell you why these high and low pressures are created. Firstly, see the diagram and analyze it. I will be telling you why these high and low pressures are created. Leave that. Right now, just understand from a very simplistic perspective. Supposingly, this is a high pressure region and this is low pressure. So by default, you realize there will be certain winds will be moving from high pressure to low pressure region. So these winds which are moving from the high pressure to the low pressure regions, because they're coming from the northeastern direction, these are known as northeastern trade winds. Subtropical high pressure. From here also some winds will move to the low pressure. So this is moving from the southeastern direction. This is known as southeastern trade winds. But you realize this, if there is high pressure, there is low pressure here also. So some winds will be flowing here, some will be flowing up there also from the high pressure. So from high pressure to low pressure. So these flowing from subtropical high pressure to subpolar low pressure are westerlies because they're flowing from the west. Similarly, westerlies over here. Now you know there is high pressure over here. This is low pressure. So from that cold region, there are certain winds blowing. Those are known as polar easterlies because of the east from there coming from eastern direction. That is known as easterlies. So these are what you are seeing, easterlies, westerlies, trade winds. These are surface level winds which you are talking about. Now, in order to compensate that, you have higher level winds also. See here. Supposingly, this is moving in this direction. These winds are surface level winds. So this is also surface. Now, when this is surface, you realize this is low pressure region. There will be air will rise. It will move. Now these, do you realize this above the trade winds? This is moving in the opposite direction. This is moving there, trade winds. Upper air winds are moving in the opposite direction. So these are also known as anti-trade. Above the trade winds in the upper atmosphere, the compensatory winds or the ones which are going in the opposite direction to compensate for the space that became vacant, those are known as anti-trade. So these trade winds are surface level, then they over here, when they move here, they rise because of the low pressure, and then they move here, then again they sink. Similarly here, now you will say why it is rising. Please understand. This is a region because it receives a lot of insolation, lot of heat. So there is very high temperature here. It will rise, right? So that is why the air will rise. Now when it will rise, it will diverge. It will move, some will move in the upper direction, some in the lower direction. So please understand, right now these words which I have mentioned, I'll explain you. Now it will move, go down. Now because of the sinking of the winds, there is high pressure here. Similarly, high pressure, it will move here, it will move here. Then again rise here because it is low pressure. Now the problem that arises is most of you will ask her how this high and low pressure are being created. Understand this now. Equatorial low pressure, this equatorial low pressure, you know that very well. At the equator, there is a lot of insolation, right? That is why this low pressure is induced by what? Because of the thermal factors. Thermal, that means heat. Majorly due to the thermal reasons. Thermal reasons over here means due to the insolation that is received from the sun. The temperature rises tremendously, and that is why it leads to rising of the air. When the air rises over here, it creates low pressure. So hence the surface winds or trade winds converge. Now see, understand here. Over here you realize these winds rise, these move. Now you realize that I'm showing you equatorial low pressure, but do you realize when these northeast trade winds and southeast trade winds will come, they will converge. The region where they are converging is known as intertropical convergence zone, ITCZ. The surface winds are the trade winds. This zone of convergence is known as intertropical convergence zone. Clear? So that means the equatorial low pressure is created because of the thermal factors. Done. Now let's see. Subtropical high pressure. Now why is this subtropical high pressure created? This is something very interesting. Actually, this is created because of the dynamic reasons. What is this dynamic? Did I tell you something? If I intentionally make you sit on a chair, that iron chair, there will be pressure exerted on that particular chair. Though I have forced you to sit, then also there is pressure exerted, that is high pressure on that particular chair. Similarly, please understand, when these because of the high temperature in these regions, the pressure basically decreases because there is rising of these air. Now you know that very well that these anti-trade winds are moving in the upper atmosphere in order to compensate for the vacuum that, or vacuum would be a wrong word, in order to compensate for the space that is left vacant by the trade winds which have flown from this region. So these will go and sink in this particular region. Because of this sinking, a high pressure is created. That is why subtropical high pressure due to dynamic reasons, not directly thermal, formed due to the subsidence of the anti-trade. What are these? These are anti-trade because it is opposite of the trade winds flowing in the upper atmosphere. It is flowing and subsiding down. When it's subsiding, that is moving down, it is exerting pressure. That is why high pressure here and high pressure here. Clear? Now comes subpolar low pressure. You'll be thinking, sir, it is a cold region. How can low pressure be created? Because you had mentioned that low pressure is associated with temperature. Over here, low pressure is not associated with temperature. We'll see this also now. Subpolar low pressure is formed due to mechanical reasons. See, these points you will study when I'll be teaching you fronts concept after about few minutes. Not directly thermal, but due to the formation of atmospheric fronts along with warm air mass forced to rise, causing the low pressure. What happens is, we will be studying the concept of air masses. What happens over here is, see, the concept of the front formation takes place. Over where what happens, see, where the warmer air is forced to rise, causing low pressure. Supposing this is a warmer air, a colder air is coming. It is air masses, we'll study that concept. Because of that, the warm air, because of that, is pushed up. Why it is pushed up? Because colder air is more denser. So warm air will be pushed up. If the warm air is pushed up, it is a mechanical force due to which a low pressure is being exerted or low pressure is being formed in that region. That is why the reason where subpolar low pressure is created is because of the mechanical reasons, which we will see in the topic of fronts when we will be going there. But when I talk about polar high is because it is such a cold region, such a low temperature is there. So that is why high pressure is created there. So polar high is due to thermal origin because of the low temperature. So what do you see over here? Now what you have understood? You've understood why equatorial low. Now let us revise it again. Equatorial low pressure is created for the reason that because of the thermal impact. Thermal impact means because it is receiving sun rays throughout the year, and that is why the temperature is high, and the temperature high means that there is the air over here will rise vertically upward. If it is rising vertically upward, what is happening? The low pressure is being created. Now when low pressure is being created, so this is why it is equatorial low pressure. Now the equatorial low pressure is created, so from the surrounding regions, the winds will come to take that place. Now these winds which are coming are northeast trade winds and southeast trade winds. Now when the air rises over here, obviously it will move in either direction because it cannot go beyond tropopause. You know that it cannot go beyond tropopause. So it will move in this direction. After rising, moving in this direction. After some time, it will cool and subside. Where it's subsiding is creating a high pressure here, So that means the high pressure created in these the 25 to 30 degrees north is or south is because of the dynamic reasons, because of the subsidence of the anti-trade. When you go to the subpolar low pressure, it is because of the creation of fronts where the warmer air mass, which we will be studying, is basically forced to rise because of the colder air mass. Because of that rising, there is a mechanical action that leads to the formation of low pressure here. The polar high or high pressure is created because of the low temperature that is present. Very low temperature is basically leading to high pressure. Similarly, as high temperature leads to low pressure, similarly very high pressure leads to just to correct it, when a very low temperature leads to high pressure, very high temperature leads to low pressure in a normal ways, normal sense. Obviously, there can be when mechanical forces or dynamic forces are acting, there are changes. Similarly, that is why as thermal factor is important here because because of the high amount of insolation that is being received. So high insolation, high temperature leads to low pressure. Low insolation, low temperature leads to high pressure. Clear? Okay, so we have done. This is a basic representation how it actually appears on the map also. Let's move ahead. Now see this very well. This is tricellular meridional circulation, a very simple version of what we had done over here. This is also Headley, Ferrell, and Porolsel I've already mentioned here. If you see over here, do you realize I've just taken the northern hemisphere? Do you realize this, that these are northeastern trade winds moving? And over here, you saw the air rising from the low pressure region, equatorial low pressure, moving. These are what? Anti-trades. What are these? These are anti-trades. And it is then sinking down here, creating a high pressure over here. So you saw here, subtropical high pressure, right? Subtropical high pressure. So over here, subtropical high pressure is being created. So this box of circulation is known as Headley cell. Headley cell. Similarly, if you see over here, these are westerlies at the ground surface. Similarly, see here, westerlies. It rises over here, then moves and then sinks over here. So this is known as Ferrell cell. This is known as Ferrell cell. Similarly, over here, we saw what? The polar easterly is moving because of low pressure rising, because of the front creation, and then moving upward and then sinking. So this cell is known as the polar cell. This is how, in a way, you realize this, that concept can be asked also. This is the way circulation is taking place, right? Heat energy is also being spread to the various parts also. So this is something very important that you should understand. Similarly, it's taking place in the southern hemisphere. If you have understood this, it is easy to understand this also, right? Now, important. You know that very well. This is how the wind belts shift. I have marked here 5 degree, 5 degree, 25, 30, 35, 60, as we have seen over here, right? So I've simplified this by making this particular diagram. See the middle one. The middle one is at the time of equinoxes. Equinoxes means that when the sun rays are vertically over the equator, which is on 21st March and 23rd September. Now, you see the wind belts are moving in this manner. These are what? The trade winds. These are what? Again, so this is a similar manner which you have studied. See, if you see here, what are these? The trade winds and westerlies. We have taken this part only. Similarly, what you see? These are what? The trade winds and these are the westerlies. Clear? Now, you realize that during the time of 21st June, you realize that the sun rays are directly over the Tropic of Cancer, northern hemisphere. So the wind belts will shift upward. Now you see wind belts have shifted a little bit upward. During the time of December, you will realize this, that the sun rays are directly over the Tropic of Capricorn in the month of December. So sun rays will be falling directly on the Tropic of Capricorn. So the wind belts will shift a little southward. Now, why this shifting is very important is, please understand. This impacts the weather conditions of various regions. One question that is repeatedly asked in the civil services preliminary also and mains also. One question, please understand. Why Mediterranean region, which lies between 30 to 45 degrees, western parts receive rain in the winters? See here, 35 to 40. Now see here. If you realize over here, this is December. Now, Mediterranean region is receiving rainfall during the month of December, but not during this time of summers. What happens is, during the time of summers, the Mediterranean region, which is between 30 to 40, comes under the influence of what? These winds, trade winds, which is not actually giving them rain. But on the other hand, when during the time of winter, they come under the influence of these westerlies. And because of that, they are carrying some water or moisture, and their western parts are basically coming under the influence of giving them rain. That is why the western parts of the Mediterranean region receive rain. This question which I mentioned over here, I want the answer also written in the comment section. Let's see what you answer. This question has been asked also repeatedly. Just analyze the pressure belts again. I said 35 to 40. Now, do you realize during the summertime, it is this part? So rain will be received during that time. Over here, it is coming under the influence of the westerlies, right? Westerlies. So that westerlies are basically carrying rain from the oceans or seas, and they're full of moisture, and they give it to the western parts of the Mediterranean region. That is why they receive the rain. Clear? So I want this answer, let us say in few lines written in the comment section. Let's see how you write the answers. I will be commenting and replying to the answers also, right? Okay, let's move ahead. Let's see the local winds. Now, when I talk about local wind is a very simple concept that they are located to a certain region and impacting a certain particular region only. Questions have been asked repeatedly on these. So these are wind systems which are generated purely by the local factors, and zone of influence is quite limited. That means when I talk about trade winds, westerlies and all, these winds are on a massive scale. On the other hand, these are local winds which will be influenced very small regions. Over here we see land and sea breezes, mountain and valley breezes, and other local winds, which I'll be showing you on the map. When I talk about land and sea breeze, let's see. If you understand this, it will be easier to understand the other concept also. During the daytime, you know that the first you should understand if you want to understand the land and sea breeze. This is again very simple, you have done in the schools also. Land has a property that it heats also very quickly and cools also very quickly. Sea takes a lot of time to heat also and cool also because of the specific heat, right? During the daytime, you realize that the land heats up very quickly. It's heat up, so what will happen? The temperature becomes very high quickly. So the air over here will rise. When it will rise, it will move to this direction. Why it will? Because this, see, when the air has risen from this region, it becomes vacant here. So obviously, wind from some other region will come here. That means wind is basically blowing from sea to the land. That is why it is known as sea breeze. So that is why while it is moving here, the air rises here, moves and then settles down. Moves here and settles down. So this is again what is sea breeze, because the winds are moving from the sea to the land, because during the daytime it heats very quickly. The reverse happens during the night time. The land cools very quickly, so that is why you realize it's moved from this direction and the opposite happens. This is what is the land breeze, where the air is moving from land to the sea, and this is what is the representation. Why? Please understand, this is also relative. During the night time, the land becomes more cold. The sea is relatively warmer. So it is again relative. Over here, just a minute. Over here, what happened? During the daytime, the land got very hot, so the air rose up. The sea took a lot of time, because it will take a lot of time to the temperature to rise, right? It will take slowly. But land will become very hot, so that is why air rose over here, and this is the direction. And movement of wind from sea to land. This is the major important thing, sea to land. On the other hand, during the night time, the land becomes very cold because it gives out heat very quickly, but the ocean or the sea is warm. So because relatively it is warmer, the air is rising up, it is moving in this direction, settling down. So the movement of air is from land to sea. Because it is from land to sea, it is known as land breeze. Clear? Okay, clear everybody? Land to sea. Let's move to the next thing, mountain and valley. Now please remember, during the daytime, these valleys and all also become very hot. So what happens? The wind, or let us say the air, basically starts moving upward. Because why? It is heated, so it will rise. So this rising of this particular wind over here across the valley upward is known as the valley breeze. This happens during the daytime. During the night time, again it cools down, and this basically comes down here. It is because cooled. So this moving down is known as the mountain breeze during the night time. This is again simple concept, local concept happen during the valley regions. This is something very clear. Okay, let's move ahead. Now comes the other local winds. These are some things, names that you should remember. The ones in the red are ones which are of hot nature. The ones in the blue are cold. Clear? So you should know the names. I could have simply mentioned the names and the reasons, but maps basically helps you. So over here you have Chinook, across the Rockies, again Santa Ana. These are again warm. These are cold local winds because these local winds are basically influencing the local regions. If let us say blizzard come, it is basically going to decrease the temperature very tremendously. Supposing the Chinook, basically it helps as a increasing the temperature. It helps to lessen the melting of the ice in these regions. So these local winds are basically influencing the local factors. Chinook and Santa Ana, North American region, warmer. Blizzards and norther, again, these are the colder local winds. If you come here, Harmattan, again warm. Sirocco, again warm. Khamsin in the Egypt region, again warm. Then you have the Foyen, again warm. You have Bora and Mistral, which are cold. If you come to Australia, you have the Brickfinder, again, which is warm. And Nor'westers over here in New Zealand, again warm. So these are the local winds that you should know. Quickly note it down also. You can draw a map also later on. Okay, let's move ahead. Now, next concept comes air mass. You would be very shocked to hear that this question has been already asked in the examination. What are air masses? And unfortunately, many people who do not study, because in the NCERT only one small paragraph of air mass is written. Nothing else is written. So people think that how can a question be asked? But the question was asked. Yes. So 15 marker question was asked. So you should be aware of the concept. If you are aware of the concept very clearly, you can write your answer also. But if you do not know it, how will you write it? Now please understand. When I talk about air mass, what do you understand? A mass of air. But if mass of air to be called an air mass, there have to be certain dimensions. Now see here. When an air mass remains over a homogeneous area, what do you mean by homogeneous area? Homogeneous area, let us say, which has specific uniform characteristics like temperature or humidity. So when an air mass remains over a homogeneous region, I am talking about, let us say there's a surface. Why it is homogeneous? Because let us say of its characteristic, whether it is warm, hot, and a mass of air is lying on top of it. This is a surface, homogeneous region or area, and a mass of air that is lying on top of it. For us, when an air mass remains over a homogeneous area for a sufficiently longer time, it acquires the characteristics of the area. That means if this surface is, let us say, warm, and an air mass is lying on top of it, if it is on top of it for a very long time, it will acquire certain characteristics of that region. Why? Supposing the air is warm, this region is warm, the temperature will be transferred to that air mass also, and it will also become warm. If the region is very cold, the ground surface is very cold, and that air mass is on top of it for a sufficiently longer time, this will also become cold. Yes. So it is basically acquiring the characteristics, provided it is there stagnant for a longer time. That is why if an air mass remains over a homogeneous area for a sufficiently longer time, acquires the characteristics of an area. Done. The homogeneous region can be vast ocean surface or vast plains. Why we are saying vast? Because if there is a small region and then another small region having different characteristics, then it is difficult to form proper air masses. Because there is variability, it is not homogeneous then. It will become heterogeneous region. Homogeneous means large area with similar or uniform conditions. That is why then the whole air mass that is on top of it will be having uniform characteristics. So what do we see? Let's see the definition. The air with distinctive characteristics in terms of temperature and humidity is called air mass. Air with distinctive characteristics. Now air over here, let us see, a region is there and a large amount of mass of air is there. And because of this contact, it has acquired certain characteristics with respect to temperature, with respect to humidity. Now this is known as air mass. That is why the air with distinctive characteristics. Distinctive, that means it has its own characteristics, which is uniform also, almost uniform in the across this large mass of air. This is known as air mass. Now the homogeneous surface on which the air mass forms are known as source region. Now till now we were talking about the region and the mass of air that is on top of it. The mass of air on top of it is known as air mass. This homogeneous region is known as source region. Why it is known as source region? Because this is the source through which this air mass is acquiring its characteristics. Clear? It's acquiring its characteristics. That is why it is known as That is why it is known as the source region. Again, let's see it again. If supposingly, we'll see that through the diagram also, don't worry. A large mass of air, let us say this is the region of, complete region of, let us say North American region, huge. Let us say northern part, let us say United States or Canadian region. Huge mass of air is there, and the region over there is very cold. So the air on top of it will acquire that cold characteristics. Plus it is continental part also, it will be a continental air mass also. Then we'll see the continental polar, or continental and marine also, but this is the region what that simply understand that air mass will acquire the characteristics of that particular cold environment uniformly, almost uniformly. So that means the region through which it is acquiring the characteristics is the source, and that mass of air on top of it is known as the air mass. So see here, so we see the air with distinctive characteristics in terms of temperature and humidity is known as air mass. Homogeneous surface over which the air mass forms is known as a source region. I'll be telling you through the diagram, it will become easier for you. Now see, before this also, let us see for 2 minutes. Leave the terminology that I mentioned, MP, CP, leave that for 2 minutes. Do you realize this large mass of air is present here? Now, if it is there for a very sufficient long or sufficiently longer time, it will acquire the characteristics of the source region which is below it, and it would have similar characteristics because it is there for a long time. This is known as an air mass. Now, this air mass can be on top of continent, as mentioned. That will be known as a continental air mass. It can be formed over an ocean also. It will be known as marine air mass. Yes, so we'll come to that, right? So let's come back here. We have understood what is air mass. Now let us understand the major source regions. What are the major source regions? This is mentioned in the NCERT also, you should be aware of. Warm tropical and subtropical ocean. These are those regions, if the mass of air is there, it acquires those characteristics. Subtropical hot desert, it will be warm air mass again. Relatively cold high latitude ocean, relatively colder air mass. Very cold snow covered continental high altitude, and then again permanent snow covered Arctic and Antarctic. So these are those regions where very often you see the air masses. If the mass of air is on top of these regions, it will acquire the characteristics of these source regions. If it is in a cold region, it will be a colder air mass. If it is in a environment of a hot region, it will be a hotter air mass, right? Or warmer air mass, you can say. So these are the source regions, right? Now let's move ahead. A classification that you should know. This is a very simple classification. There are many classifications. If you want to ask, this was given by Trivartha, which you do not want to know, you should not know also. There is no need for general studies. There are a lot of classifications, but I've just mentioned so that you understand it. Polar air mass is conventionally known by P, tropical air mass by T. That means polar is in the higher latitudes, and tropical air mass in the lower latitudes. If it is formed on the continent, it is known by small c. If it is formed in the marine region, it is known by small m. What are the possibilities now? CP means continental polar air mass. Small mp means marine polar air mass. Small ct means continental tropical air mass. MP means marine tropical air mass. Now see the example of North America which I've shown you. CP, continental polar air mass, because it is colder, it is cold and dry. MP, marine polar, it is cool and wet. When you come over here, southern, this is marine tropical. Marine because it is in the ocean. It is warm and wet. Wet because it is the region of, let us say, ocean. And T because it is tropical, right? Over here, marine tropical again. This is cool and wet again. See, this is again marine polar. Clear? So this is again a simple representation of various air masses from the perspective of North America. Clear? Now, let's move to the concept of fronts. Very, very important. If you've understood the concept of air masses, now let us understand what is fronts, which we had studied when we were studying the pressure belt. So that is why you should understand what is fronts. When two different air masses meet, the boundary zone between them is known as a front. Very, very important topic. Just note it down. What is written here? Let's see. What do we understand by fronts? Come on, tell me. What do we understand by fronts? What we understand by fronts is, see, when two different air masses, see here, two different air masses, why? Because if two different air masses are there, they will be having different temperature, different humidity, different parameters. That is what is important. If if there are no differences, then the front will not be formed. So, supposing that this is an air mass, which is, let us say, colder. This is a warm air mass. Let us say these masses come and collide. Let us say come together. The boundary, the zone where they are basically meeting, this zone basically forms the front. What does it form? It forms a front. And the process of formation of fronts is known as frontogenesis. Frontogenesis. Let's see here, simple. Very simple diagram. Let us say this is an air mass. Let us see here. This is a mass of air. This is supposingly another mass of air. This is moving, let us say this side. Let us assume, let's see this. Now, after some time, what happens? What is this? This is a front. I'm taking this as, let us say, warm, this as cold. Simple understanding. The two different air masses meet, the boundary zone is known as a front. Two different air masses, because these air masses, greater the variation, stronger is the front. If greater the difference is in the temperature or humidity is, temperature predominantly is there, greater is the intensity of the fronts that are formed, right? That is why you will see certain questions, why fronts are not formed in the equatorial regions. Why? Because the temperature uniformity is there. But when you go to the regions which are present here, over here, see, let's see. Over here, you realize there are certain warmer also regions, warmer air masses also coming and cooler air masses also coming from that region. So we realize there are certain regions where fronts very often happen. See here, subpolar low pressure regions, if you see. Over here, warmer air masses also going and colder, very cold air masses also coming. That is why this is a region where subpolar low pressure regions are the where you find a lot of front formation taking place. Because warmer air masses from the lower latitudes are moving and colder air masses from the upper region. While in the equatorial region, you realize it is uniformity of temperature is there. So you do not see front formation, because for that, the air masses should have a lot of variation in their distinctive characteristics, which I had mentioned in what? While defining the air masses also, right? So let's see here. So this is frontogenesis, formation, process of formation. Fronts is the boundary. Now let's see, there are four types of fronts. First is stationary fronts, cold front, warm front, and occluded front. What happens is, this is red color warm air mass, this is cold air mass. Now, when the air masses are not moving against each other, they're not moving against each other, they're just coming close here, right? That means there is no temperature gradient because they're not crossing, they're not moving against each other. So this is a stationary stage right now. Their stationary stage. This is known as a stationary front. It is not a proper front that is formed. It is the initial stage. There is some convergence taking place, but they have not crossed each other, right? So, or moved against each other. That is why it is just stationary stage. That is why it is known as stationary front, just the beginning stage. Cold front. When the cold air moves towards the warm air, the contact zone is known as a cold front. When the cold air is moving towards the warm air, this is known as a cold front. Warm front, when the warm air moves towards the cold air, this contact zone is known as a warm front. When the warm air is moving towards cold air, it is known as the warm front. Now what happens? After some time, when both the airs are coming, what happens? It is possible that the air might be lifted up. If the air mass is fully lifted above the land surface, it is occulted. Over here, see, over here you realize this warm air over here is completely pulled upwards. So this region is known as the occulted front. Occulted front. So that when an air mass, when a part of air is again lifted upwards, over here, when the air is fully lifted upward, then this part is known as the occulted front. That means finished, right? Okay. These are the four fronts. Please write it down, make the diagrams. The question is, why subtropical low pressure belts is a very prominent zone for the front formation? This is question number 2, which you have to write in your comment section. Briefly, these are questions which are asked in your civil services preliminary as well as mains examination. Okay, let's come to the next topic, that is cyclones and anticyclones. Now see, please understand this is a diagram that you should always remember. What are cyclones? Cyclones are low pressure systems, right? Low pressure systems where the movement is taking place in an anti-clockwise in the northern hemisphere and clockwise in the southern hemisphere. As anticyclones are opposite of that. Anticyclones are high pressure systems where the movement is basically, the pattern of wind movement is basically clockwise in the northern hemisphere and anti-clockwise in the southern hemisphere. Let's see here. When I'm talking about, let us say something like this. This is low pressure. These are what? These lines are what? Isobars, right? Now just see this. First thing, tell me, when you see a surface which is, let us say the winds are moving in a circular path over here, right? Second thing, do you see there is a low pressure? When the low pressure is there, what will you say? It is a cyclone. First. Now it is moving. Do you see the direction of movement is in an anti-clockwise manner? Anti-clockwise. It is not moving in this direction. It is moving in this direction. So what it is? Anti-clockwise means northern hemisphere. Clear? Similarly, when you realize, you will see if it is moving in a clockwise manner, it is what? If it is low pressure and moving in a clockwise manner, what? Then it is going to be a cyclone which is present in the southern hemisphere. Anticyclones also you'll study later on in this chapter only. So broadly you've got an idea. Cyclones, again, these are low pressure systems which are moving in a anti-clockwise direction in the northern hemisphere and clockwise in the southern hemisphere, whereas anticyclones are high pressure systems which we will be seeing after cyclones completion, which are moving in a clockwise direction in the northern hemisphere and anti-clockwise in the southern hemisphere. Now we'll see this. Wait. First, let us see cyclones and study them. When we are studying the cyclones, and then we'll study them in detail, and then we'll study the anticyclones. When I talk about cyclones, these are what? Low pressure systems. When I talk about the types, please understand there are two broad categories. First, temperate cyclones. Second, tropical cyclones. Now for temperate cyclones, it was very important for you to understand the concept of fronts and air masses. If you do not know that, you will not be able to understand the temperate cyclones. And then the reason why temperate cyclones are located in these regions, you will also get to know this. So let's see. What are temperate cyclones? First of all, when I say cyclone, what will you understand? It is a low pressure system. Second, if it is, see, cyclones are what are they? You know that basic understanding is clockwise in the anti-clockwise in the northern hemisphere, clockwise in the southern hemisphere. Leaving that point, you should know that. Now let's see. When I say temperate cyclones, that means formed in the higher latitudes, temperate regions. So that is why there are various names also assigned to them. System developing in the mid or the high latitudes beyond the tropics are known as mid-latitude, extratropical cyclone, or temperate. Extratropical means outside the tropical zone. Please remember, in the exam they can ask you tropical and extratropical cyclone. You will get confused otherwise. The temperate cyclones are also known as mid-latitude cyclone, extratropical cyclone, and temperate cyclone. Clear? Let us understand certain features before I explain you how they are formed. See, these are formed due to horizontal temperature differences between two air masses. That means because of the air masses, the front formation takes place, and that leads to the rotatory path, which leads to the formation of temperate cyclone, which we'll be seeing. That means for temperate cyclone, frontogenesis is a major dimension. Without that, temperate cyclone is not temperate cyclone, right? So front formation, that means frontogenesis, is something very important. That is why the fronts is the basis of this particular concept. Velocity, it rarely reaches more than 100 degrees. So that means the velocity is relatively less. In tropical cyclone, it is very high, right? We'll do that. Diameter from 150 to 3000 kilometers also. Vertical extent is 9 to 12 kilometers. It is never completely circular, please understand. Frequent in regions between 35 to 60 degree latitude, because you know these regions are where front creation is very common. Can form both on land and ocean. It can form on land and ocean both, because it is basically dependent on the front formation. Special compartments or cell exist, or sectors exist, which I'll show you, which is not present in a tropical cyclone. Whatever points I've written here are also points of differences with a tropical cyclone. You will see when I will be doing a tropical cyclone. Now, this is the formation. Now, please understand. Please see there are certain standard connotations which I'm using here. Let us assume that this is a blue colored is a what? Cold air mass. What? Cold air mass. This is a warm air mass. Now, this symbol of these lower sided arrows of blue color and red color, this is known as stationary front representation. That means right now they just come, but they have not again, just let us say they have not collided properly right now. They are just in the process, in the close to each other, right? There is little bit convergences, they're not but proper. So that means this is right now a stationary stage. That is why this is known as stationary front. Now what happens? The moment it is coming, there is again upliftment, the air mass is being uplifted, the warmer one, and some twisting happens. So the moment the upliftment happens, the lower pressure is created and this twisting is happening. This is again the representation of warm front. This is a cold front. The moment it starts rotating, this is again a circular motion is being established. So this is again what? A cyclone is being established. Now this again starts turning more. Again it is mature stage. When it basically combines, you see this purple color is a occluded fold. That means the ending stages begin and then finally dissipates. So it is basically the fronts which are coming together, and because of that, obviously the warmer air will be uplifted, and you know that the turning will start. The moment the turning starts, this cyclonic conditions starts, and it is why temperate cyclone, because it is in a temperate region and fronts are basically involved in this particular process. That is why it is known as again basis. The front or frontogenesis is the basis of the temperate cyclone. So this is the formation stages. So let us write it: 1, 2, 3, 4, 5, 6. Clear? Red color is associated with warm and warm fronts, blue with cold or cold fronts. Now please understand this. When you see these dimensions, there are a lot of things that are associated with each and every element that I mentioned here. Now let me show you this. This is known as the warm sector. This is known as the cold sector. This red color, you know, this is because of the air mass that was warm. So can I say this is what? Can I call it, let us say, warm sector? Warm sector means this region. This region is warm sector. This region is the cold sector, right? This is the warm front. This is the cold front, right? So let's see here. This is what? The warm front. If you see over here, I mentioned here was sector. So see here, this is the warm sector. That means where warm air mass is. This is what the warm sector is here. Similarly, this is what is the cold front. And this is what is the cold sector, where cold air mass is there. Now, related to this, there are weather associated with, different weathers are being associated within a particular temperate cyclone. That is why I told you there are compartments existing, cell existing, and within a temperate cyclone, you realize there are variations existing within the temperate cyclone with respect to the weather conditions. Let's see. The warm sector Please understand. Let's see the warm sector. Was the warm sector, see what happens is sky becomes cloudless and clear, sudden rise in air temperature and increase in specific humidity seen. The warm frontal region has precipitation, thick clouds and very heavy rainfall happens. So you know when I'm talking about warm sector, increase in temperature, warm front over here, very heavy rainfall happens. Cold front is marked by decrease in temperature. Cold frontal precipitation happens, heavy downpour and thunder and lightning happens there. And in the cold sector, there is sharp fall in temperature. Now, this is again something not present in the NCERT. I have drawn these formation, I've drawn the sectors which are there, I've drawn the fronts there and the related associated weather also. Clear? So, the question which were asked in the examination was something that you should have the knowledge of this subject or this topics. Otherwise, you would have not been able to write in the examination. Let's move ahead. Tropical cyclones. You know, when I talk about tropical cyclone, we're talking about the tropical region. So tropical cyclones are violent storms that originate over the oceans in the tropical areas and move towards the coastal areas, bringing about large-scale destruction caused by violent winds and very heavy rainfall. Please understand this, that first of all, unlike the temperate cyclones, the temperate cyclones are formed because of the frontogenesis. That means fronts can be formed over the land also, and they can be formed over the oceans also. So their formation is dependent upon fronts. So that means they can be formed over the land and oceans also, no problem. But tropical cyclone basically derives their energy from the water. Now what happens is, when water gets heated, it basically, let's just say vapors rise. When they cool, latent heat is released, and that is why the tropical cyclone works like an engine, right? Heat engine, and that energy is continuously supplied and keeps on going. That is why tropical cyclones are formed only over the water bodies or oceans or seas. The moment they come across the coast, they might cause a lot of destruction, but as they enter the coast, because their supply of water ends, so the tropical cyclone also finishes. Unlike the temperate cyclone, because it is based on frontogenesis temperate cyclone, this is based on water as a means of energy, because when water gets heated, it rises in the form of vapors. When it rises, it cools. When it stays in state, the latent heat or the hidden heat is released, which again cycles the whole process, again that convective cycle to take place. This can only take place if the water supply is there. If it is not there, it will end. So that is why we say that these rise over the tropical oceans, tropical areas, and originate over the ocean. And when they move towards the coastal region, they bring a large destruction because they are very strong. But as they move inside the coastal region, they will die because the source of water has ended. Favorable conditions, large surface area with temperature higher than 27 degrees, large sea surface, again sea surface, higher the temperature, better it is. Presence of Coriolis force, so that again Coriolis force basically helps to form the cyclones, right? Because of the because of deflection that is caused. Small variations in vertical wind speed, pre-existing low pressure might be existing, which basically helps. Upper divergence among the sea level, again basically helps in the formation of the tropical cyclone. Now, what are the features here? Latent heat, again as I said, hidden heat that is released when you change from one state to another, latent heat is basically released. So that hidden heat is basically boosting this particular process. Velocity is from 20 to 30 kilometers per hour to even 300 kilometers per hour. That means very fast speed. Diameter 80 to 300. Vertical extent 15 kilometers up to 15 kilometers. The location is from 5 degree north to 5 degree south only. So this is a limited portion. Forms only in oceans or seas, as I've told you the reason. It is basically known by various names. Cyclone in the Indian Ocean. This has been asked in the civil services and PCS repeatedly, right? Cyclone in the Indian Ocean, hurricanes in the Atlantic Ocean, typhoons in the Western Pacific and South China Sea, and willies in Western Australia. So these are certain things that you should be aware of, and please note it down, pause the video. Let us see the formation of the tropical cyclone also. We have seen the temperate cyclone. So what happens initially is, initial stage, the isobars are ill-defined and only center core is little bit there. So that means certain convergence is taking place. Slowly what happens in the formation of the infant stage, this center part is the eye is developed, and isobars are more circular. That means the cyclonic conditions is basically intensifying a little bit. Beginning. Juvenile stage, where you see there is certain again convergence and there is certain, let us say, rising, the air will rise, warm air in the form of vapor. and then certain cloud formation will take place and certain rain will also take place. So again, cyclone is again developing now. Mature stage, similarly over here, you realize this, there is intensification of this particular stage over here, where series of clouds are fully formed, full developed eye. Eye means this particular center region, and large size and high speed basically develops. Now, if you want to see this, what the NCERT shows you is only this diagram. They do not show you these stages. So NCERT, what does it show? This is the eye, which is again basically because it is a region of subsidence. That is why it is again very region of calm. But as you see over these regions, as the air rises, you realize there's cloud formation taking place over here, and these cloud formations again lead to a lot of rainfall, a lot of speed, a lot of destruction when it enters the coastal regions. But this eye is a region of subsidence, which is a region of generally calm, right? Okay, so this is what is the tropical cyclone. What are the weather associated with it? Sudden increase in air temperature and the wind velocity. Marked decrease in the air pressure, obviously, because these are low pressure systems, so there will be decrease. Cyclones are low pressure systems. Emergence of high waves. I, the region in the center, is region of calm breeze and clear sky. Clear? Okay, now let us see what are anticyclones. Please understand. Again, do you realize this is high pressure system? High pressure system means wind always moves in the outward direction, and it is moving in the clockwise direction, so that means this is in the northern hemisphere. What did I say? What did I say? I had mentioned that anticyclones are high pressure systems. That means if this high pressure system, that is means it is an anticyclone, because cyclone was a low pressure system. Now, if it is moving in a clockwise direction, cyclones are anti-clockwise in the northern hemisphere and anticyclones are clockwise in the northern hemisphere. So this is clockwise, moving in the clockwise direction. So this is clockwise. So this is what? In the northern hemisphere. So this is representation of a anticyclone in the northern hemisphere. These are high pressure systems. Defined as high pressure systems where wind blow outwards. Right? Now see here, features: circulate clockwise in northern hemisphere and anti-clockwise or reverse in the southern hemisphere, usually circular in shape. They are very large size. Diameter may go up to 9,000 kilometers. This is huge. Velocity from 30 to 50 kilometers per hour. Associated with it is rainless and free of sky because it is high pressure. So see, please, the climatic condition variations and large rainfall basically is one of the reasons where air rises from a particular region. That is why there is instability and a lot of rainfall. So there is sinking of air. So you realize there is generally associated with aridity and clear skies over here. So this is what is the anticyclone. So this was a chapter which you have studied. I have covered this topic in a lot of detail. I would request you to please go through this chapter very well. A lot of diagrams have been drawn here. A lot of concepts have been cleared. So please make sure that you understand, draw each and every diagram. Understand every concept. If you do not, please because see the video again. Clear your concepts and then revise. Please do not rote learn it because it is of no value otherwise. These are conceptual understandings in which you should be very clear about. God bless you. I hope you like the lecture. If you like, please tell me in the comment section how you liked it. We will be coming with the further videos also and completing the series, because I think you have generally showed a lot of love with, towards this series, and we are really liking it also. We'll be completing this series in this coming week also, the coming week, and hopefully you will be making the best use of these videos. So God bless, take care, and then I will, as I always say, Jai Hind.